Okay, welcome back. I thought I should maybe go over a couple of things today. We're going to do one more day on similar material, just applying some of the stuff from last week. So quick review then to start. We've got two sets of special triangles, or two sets of special angles coming from two different triangles. This is the isosceles triangle. And if we remember, isosceles means that we have the same length here and here. And so I've started it with lengths of 1. We calculate this missing side using our Pythagorean theorem. Turns out it's root 2. And then the various sign ratios that we need to be able to develop or know are down here. The second triangle and second set of angles that are of interest to us, where they come from, by the way, is just if we did extend this out, this would have been an equilateral triangle. And so it's essentially half of an equilateral triangle that we're looking at when we look at the 30, 60, 90 triangle. And that's kind of why it's one of the special triangles, and 30s and 60s become important to us. But same sort of argument. From the 30, I have my opposites over here. I have my adjacents over here. And of course the hypotenuse here. And so I'm able to put together a sign being opposite over hypotenuse. This is the one, if you remember, that I say I memorize. And then I build the triangle from there, whatever works for you. If you want to just learn them all, that's fine. But if you want to be able to just develop the triangle, that's probably good too. Probably better. And then these are the various ratios that we need to know. So again, my suggestion was you would basically start up your test by doing each of these triangles, and then once you have them written down, of course, knowing the various ratios is pretty easy. So making use of those. Now, this is going to be applying the cast rule and the special angles. The first one here is not a special angle at all. It's just a cast rule, but just kind of remembering sort of what cast tells us, and of course what it means when we read this specific question. Find the trig ratios for this point. So we want to recognize where this point happens to be. This is in XY combination always. So 6 in the X direction, and then negative 7 in the Y direction. Means that my line is out here. From what we've seen before, we're always kind of interested in our butterfly. And so the angle that I'm going to be dealing with will always be the angle that comes from the butterfly. So in this case, my triangle is right here, and my focus angle is going to be in here. My two sides then, or the numbers that I know, I have a 6 and a negative 7. A 6 in the X direction means that I've gone 6 this direction. Negative 7 means that this length is 7, but the actual location is down 7 or negative 7 from the axis. So to find the trig ratios, of course, I need to know what sine. I'm looking to find sine, I'm looking to find cos, and I'm looking to find tan, which means I need my opposite and hypotenuse and adjacent in each case. And so I don't yet have my hypotenuse, but same as we just sort of suggested with the basic ratios, or the special angles, I should say, to find this missing hypotenuse, we can do the same thing here. So c squared will be the 6 squared plus the negative 7 squared, which is 36 plus 49, which is 85. And so my c value will be root 85. Because I'm looking to write these as ratios and as fractions, root 85 is still going to be a much nicer answer than whatever the decimal equivalent is. And so I'm going to keep the root 85 as we did with the other questions and simply write down the ratios. So sine now is the opposite. The opposite of the angle in here is the -7 over the hypotenuse, which is the root 85 that I just calculated. Cosine of the angle is going to be the 6 over the root 85. And tan is going to be the opposite, the -7, over the adjacent +6. And one thing you sort of notice, or you may notice right away, is that as we would expect, going from the cast rule, down in the quadrant where we're working, cosine is positive. The other two are both negative. Okay, so that sort of gives me a pretty good indication that maybe I did things fairly well. As far as finding the trig ratios for a given point, that's all we're looking to do. Now, of course, we've gone through this a few times. If we needed to find the actual angle, we would take one of those and punch it into a calculator and solve it. But for as far as writing the ratios in their best possible form, in their most accurate possible form, these are our answers. Second question here, find the values of theta where 0 is less than or equal to theta is less than or equal to 360. And then I've got right below it, determine two angles between 0 and 360 degrees that have a cosine ratio of 1/2. Do not use a calculator. Okay, so essentially these become the same question if I'm given the cosine theta equals 1/2 for the first part. Okay, so sort of this and this would be given as one question, or alternatively, this could be given as just another way to say the same thing. And so what we're looking to do is solve this as best we can. Find the values of theta where, right, okay, so what we want to recognize is, first of all, when cosine is 1/2, that is one of the basic trig ratios, or one of the special angles that we know. If it's not, the question's a little different, but in this case it is. So this one already tells me, just by knowing this ratio, that one of my answers is that theta is 60 degrees. Once I know that, then I know that, again, that's one of my answers, but I also have a second answer somewhere in my butterfly. And so the question is, since cosine has to be positive 1/2, which area am I going to, which quadrant will I be in? Well, I'm in the first quadrant for all things being positive, sine, tan, and as we just saw in the previous question, I'm going to be in quadrant 4 in order to have another positive cosine. And so what that's telling me now, I'm pretty much done already, that means this is 60 degrees in here. And because I want my angle to be between 0 and 360, I can start here and kind of rotate around until I get to this terminal arm, or this line that will help me finish up. There's 60 degrees that's not been used up. That means there are 360 minus 60, 300 degrees in the angle that I'm looking for. So my answers are, when does cosine of theta equal positive 1/2? When theta is 60, and when, therefore, theta values are 60 degrees and 300 degrees. I suppose when cosine of theta is 1/2. Now, if the question had been slightly different, I'll just sort of make note of this. If the question had been something like, cosine theta is 1/4. That's not one of the ratios I know. And so what I would do then would be actually use the calculator, find out what the value of theta is in that case. And I don't have a calculator here. Okay, so inverse cos of 1/4 gives me approximately 75.5 degrees. And then using the exact same idea up here, I now have same diagram, but 75.5 in here. So that means I have 360 minus 75.5, which is 284.5 degrees. And so essentially now my two angles are the 75.5 and the 284.5. So those are basically the things that we can do fairly straightforwardly, knowing the cast rule and knowing how our angles relate one quadrant to the next. Obviously more advanced questions are possible as well, and you may run into them today or if not in the near future, but establishing this is really where I wanted to go for now.